So welcome back to the new class. In this video, I'll be discussing about the factor theorem and the remainder theorem. So mainly in this class, we'll learn about how to factorize any polynomial. So in last class, we started with the chapter polynomials where we studied the introduction to polynomials, definition of polynomials, the type of polynomials depending on the degree, depending on the number of terms, what type of polynomials are there. So that's what we studied in the previous class. Now, the learning objective of today's class is to find out the factors of any polynomial, whether it's a 2-degree polynomial, cubic polynomial, or any higher degree polynomial, and make use of factor theorem and remainder theorem if in any question it is asked to find out the remainder, or if in any question we just have to check whether any binomial, any linear factor, or any quadratic factor is one of the factor of the given polynomial or not. So first I'm going to cover the basics of how to factorize, what is the conventional method, and then by using factor theorem or remainder theorem, how can we solve a problem very quickly, because in digital SAT, time and accuracy, this is what we have to manage, and these are the only 2 points of success, we can say. These are the two main keys of success to 1500 in digital SAT. So, without wasting any time, let's just dive into first the prerequisites, what we have studied in the previous class. So, we have studied the definition of polynomial. So, what are polynomials? So, we know that if there is an expression, let's say I'm writing some expression x to the exponent 5 plus 4x square minus 3x cube plus 2. Now, this is an expression, of course. Now, how many terms are there? This has 4 terms. This is first, this is second term, this is third term, and this is fourth term, right? Now, what as per the definition of polynomials, what we have to do, so we have to check that each and every term, each term's exponent must be a whole number. So this is first term, and 5 is the exponent of the first term, which is nothing but a whole number. Similarly, look at the exponent of the second term. So this is 2, which is again a whole number, and this exponent is 3, and this exponent is 0. So this is a constant, so I can write it as 2 into x to the exponent 0. So this term's exponent will be 0, which is again a whole number. So it is satisfying the definition of a polynomial. Hence, we can say that yes, this expression is a polynomial. So basically, we have to check that if an expression is given, then every term's exponent. What is the meaning of every term's exponent? So term's exponent means what is the variable's power, what is the exponent of the variable. So that exponent must be a whole number for every term, then it will become a polynomial. So that's the simple definition of polynomials. Now we can have a look at few examples. So like x squared plus 2x, and x plus x to the exponent 30. 10 is also a polynomial. This is called a constant polynomial. And x minus 1 is a linear polynomial, also we can say. A binomial also we can say. Binomial means because it has 2 terms, and linear polynomial based on its degree. Whereas x plus root x. So why x plus root x is not a polynomial? Because look at the first term. So its exponent is 1. It's a whole number. We don't have any problem. But now look at this square root of x. This exponent, if I write, this is a fraction, which is not a whole number. Hence, just because of this term, this is not a polynomial. Similarly, whenever you see an exponent as a fraction or a decimal number, then that cannot be a polynomial. In fact, if you find a negative exponent also, whether it is a integer, so if negative integer is also there, then also it won't be a polynomial. So exponent of each and every term must be a whole number, then only the expression will be called as a polynomial. Alright, now let's move to the next part. So next is factoring polynomial by conventional method. So how do we factorize a polynomial by simple method? Let's have a look at some example. So yeah, we can see one question here. Factor x cube minus x square minus 4x minus plus 4, right? So we have to factorize this. So by conventional method means like we have to first, by hit and trial method, we have to find a value by hit and trial method at which the value of this polynomial becomes 0. So of course 0 will not work. So if I try to put x as 1, then it will be 1 minus 4 plus 4. So that means this is cancelled out and this has been cancelled out. So that means x minus 1 is one of the factor. So after that you can go by the long division method, where x cube minus x square minus 4x plus 4, and then you will be dividing it by x minus 1 and then further solve it. But then this is a lengthy method. So if you look at the expression carefully, what you can figure out, you can see that from the first two terms, if you take x square common, then you just left with x minus 1. Then you just left with x minus 1. Similarly, from these two terms, if you take minus 4 common, you just left with x minus 1. Now, from this whole expression, we can take x minus 1 common and we just left with this x square and minus 4. So our final answer would be x minus 1 into x minus 4, or further we can factorize this x square minus 4 as x plus 2 into x minus 2. So this will be the factorized version of x cube minus x square minus 4x plus 4. So this is how we factorize by the conventional method. Alright, now factoring using algebraic identities. So you must have studied all these identities in your previous classes in grade 9 and 10. So sometimes if we want to factorize any expression, then we can also make use of these identities, these three identities. X square minus y square is equal to x plus y into x minus y, and x square plus 2xy plus y square is nothing but your x plus y whole square. Of course, this is the factorized version, right? Because we can also write this as x plus y into x plus y. Similarly, this is also because of this minus 2xy, there will be a minus sign in between x and y, and we can also write down this as x minus y into x minus y. So these identities we can also use to factorize any polynomial. Now here any polynomial can always be written into the form p of x is x minus r into qx plus p of r, where q of x is the quotient and x minus r is the divisor and p of r is the remainder. So let's understand this better by some example. For example, this is a simple one, factor x to the exponent 4 minus 16. So this is a simple question based on this algebraic identity, first one. So we can write this x to the exponent 4 as x square square minus 4 square into, so this we can write it as 4 square. Now considering x square minus y square, so we can write this as x square minus 4 and x square plus 4. Similarly, we can further factorize this x square minus 4 as x plus 2 into x minus 2 into x square plus 4. So this will be the finally factorized version, because x square plus 4 we cannot factorize it further. So this will be the factorized version of x to the exponent 4 minus 16. So now we'll study remainder theorem. So what is remainder theorem? Let's suppose you have a polynomial p of x. Some polynomial p of x is given, and then you have to find that if you divide this polynomial by x minus r, then what will be the remainder? So of course, if we think of a long division method, then it will take so much time, and in SAT we have to save time. So the best strategy, the best approach to crack such type of problems is by using remainder theorem. So how to use remainder theorem for such type of questions? So first we need to understand the remainder theorem. So what remainder theorem says? So here we have to find out the remainder when a polynomial px is divided by x minus r. So there are certain steps which you should follow. So if you follow these steps, then you can find out the remainder for any similar questions. So first step is take the divisor. So what is the divisor? It is x minus r. Now equate this divisor to 0 and find out the value of x. Now in second step, whatever value of x you get in the first step, substitute the value in p of x. So basically I can write this p of x, you have to find it x equal to r, or this is also equal to p of r. Now whatever value you get for this p of r, that will be the remainder when p of x is divided by x minus r. So p of r will be the final answer, or p of r will be the remainder when a polynomial px is divided by x minus r. Now let's consider the example. If p of x is x to the exponent 100, if p of x is x to the exponent of 100 plus 2, when it is divided by x plus 1, so divided by x plus 1. Now as per the first step, take the divisor, equate it to 0, find the value of x, that is minus 1. Now substitute the value of x in the polynomial p of x, or find out the value of p of minus 1. So it is minus 1 to the exponent 100 plus 2. Now minus 1 to the exponent, it's even power, so it will be plus 1 and plus 2, so that means 3. So finally we can say that p of minus 1 is 3, or when we divide this polynomial by x plus 1, the remainder will be 3. So that's how we solve problems using remainder theorem, or based on remainder theorem. So I hope this question is clear to all of you. So it's a two-step process. Simple. Whatever the divisor is given in the question, equate the divisor to 0, and then whatever value of x you get after equating the divisor to 0, substitute the value in the given polynomial, and whatever value of the polynomial you are getting for that particular value of x, that will be the remainder. Right? Now factor theorem. So logically, if we think about factor theorem, so factor theorem is nothing but the extension of remainder theorem, we can say, or it is just one special case of remainder theorem. Why? Because see, look at the definition of factor theorem. A factor theorem states that if x minus r is a factor of p of x, then p of r will be 0, where p of r is nothing but the remainder. So it means that, let's suppose we were checking the remainder, that when we divide any polynomial px by x minus r, then p of r will be the remainder. And coincidentally, or by chance, if we get the value of p of r as 0, then can we conclude that x minus r completely divides the polynomial px, or x minus r is one of the factor of px, then only we are getting remainder as 0. Right? So there is a logic. So factor theorem comes into the role whenever the remainder, when we are dividing a polynomial by any binomial or any linear polynomial, and we found that the remainder is 0, then in that case we can say that yes, this is a factor of polynomial p of x, or this factor completely divides the polynomial. Simple. Now consider one question. P of x is x to the exponent 7 plus k of x plus 1 has a factor x plus 1. Now guys, the question based on factor theorem and remainder theorem will be based on, like, there will be either this complete information of factor will be given, that okay, this is the factor x plus 1, and some arbitrary constants they will introduce in the polynomial, and they will give you that okay, this is the factor of this polynomial. So what will you understand from this? As per the step 1, you have to take the divisor and equate it to 0. So that means x is minus 1. Now we know that the value of p of minus 1 will be 0, because in the question itself it has they have mentioned that this is the factor, this p of x is x to the exponent 7 plus kx plus 1 has the factor x plus 1, right? So now p of minus 1 is 0, so what we can do, replace x by minus 1 in p of x, we get minus 1 to the exponent of 7 plus k of minus 1 plus 1 is 0. Now this will be minus 1 minus k plus 1 is 0. So this 1 and 1 get cancelled out. So finally k will be 0. So answer will be k is 0. So that's how you solve questions based on factor theorem. I hope this is clear to all of you. Alright, let's move forward. Now there is another concept, sum and products of roots of polynomials. So that we'll cover in the next class.